In this example, we've got an extract from the large data set which shows 8 days worth of data of maximum daily wind gust and relative humidity for that day. So in part A, we're asked to find the product moment correlation coefficient for this data. So we're going to use our graphical calculators to work that out. So we need to go on statistics mode by going to the menu and pressing 2. And then in list 1, we need to put in our X data, which is the wind gust data. And in list 2, we're going to put our relative humidity data, which is our list 2. And what we want to do is we want to do a regression, which basically means we want to put a line of best fit through this data. So we're going to just click set first by pressing F6, just to make sure that the 2var X list is list 1 and the 2var Y list is list 2. And also check that the 2var frequency is 1. And then we're going to press F3 for regression and X. And we want our regression line to have the formula AX plus B. So when we run the linear regression, we end up with the formula y equals ax plus b, where the gradient A is 0.09 and b is 84. And we get our value of r, which is the product moment correlation coefficient, of 0.1149. So we can just write that down, 0.1149. So let's draw ourselves a little diagram to help think about what this value of r represents. So in the middle we've got 0, which is no correlation, and on the right we've got a strong positive correlation, and on the left, if r equals -1, we've got a strong negative correlation. So r equals 0.1149, so we're quite close to 0. In part B, we're asked to test at the 10% significance level whether there's evidence of a positive correlation between these two data sets. So we want to work out, is this value of r close enough to 1 or far enough away from 0 towards 1 to convince us that the population correlation is different from 0, is positive. So let's write down our null hypothesis. Our null hypothesis is always that rho equals 0. So our null hypothesis is that there's no correlation between maximum wind gust and maximum humidity. And H1, our alternative hypothesis, is that, well, because we're asked to test whether there's a positive correlation, our alternative hypothesis, what we're trying to show is true, is that rho is bigger than 0. So the population correlation between the maximum wind gust and maximum humidity is positive. So we're going to have to look at our table in order to work out what the critical region is going to be, what our rejection region is. So we're working at the 10% significance level, and this is a one-tailed test. The reason why it's a one-tailed test is because we're only interested in the critical region on the right-hand side, because we're asked to test whether there's a positive correlation. So let's go back to our tables. We need to know the sample size, which is 8, and the significance level, which is 10% in that tail. So we're going to go to sample size of 8 and a significance level of 10%, which is 0.5067. So if I mark that on, 0.5067. So our critical region is to the right of that value from the table. So in this case, we can't reject H0. Our value of the sample correlation coefficient, 0.11 is not big enough to suggest that there's a positive correlation because it's not in our critical region. It's not bigger than that value from the table. So our conclusion is that there's insufficient evidence to suggest that there's a positive correlation. So we do not reject H0. And there's insufficient evidence to suggest that the data, and I'm not just going to write data, I'm going to write it in the context of the question to suggest that maximum humidity and maximum wind gust are positively correlated. So that's our conclusion. And I'm writing it like that because we were asked to explain whether there's a positive correlation or not. And we're concluding that we can't say that there's a positive correlation. Before we finish this example, I'm just going to add one extra step that I missed out. And I'm going to make it really clear to the examiner that I know why I'm not rejecting H0. And I'm not rejecting H0. I'm not saying that it's a positive correlation because 0.1149, our value of R, is less than the value that we looked up in the table, which is 0.5067.